Identify the contents of vessel 3. According to the background information, vessel 3 is filled only with nitrogen gas, N2, and contains no solids. In the initial diagram at 27 degrees Celsius, the nitrogen is correctly represented as 4 diatomic molecules, pairs of bonded spheres. Apply the law of conservation of mass. Because the vessel is rigid and sealed, the system is closed. No gas can enter or leave, and nitrogen gas does not undergo any chemical reaction in this container. Therefore, the total number of nitrogen atoms and molecules must remain exactly constant. The diagram representing the heated state must still show exactly 4 diatomic molecules. Connect temperature to molecular speed. According to the kinetic molecular theory, the average kinetic energy of gas molecules is directly proportional to their absolute temperature in Kelvin. Ke is proportional to T. Since kinetic energy is mathematically defined by the mass and velocity of the particles, Ke equals 1 over 2 mv to the power 2. Heating the gas from 27 degrees Celsius to 127 degrees Celsius increases the average kinetic energy of the molecules, which directly increases their average speed. Determine the correct visual representation. The prompt states that the lengths of the arrows represent the speeds of the particles. Because the average speed of the N2 molecules increases upon heating, the arrows in the heated diagram must be longer on average than they were in the initial diagram at 27 degrees Celsius. Diagram A correctly preserves the 4 diatomic molecules while showing them moving with longer velocity arrows. The correct answer is option A.